Let's do some problems regarding related rates. So, to do related rates, you need to find the formula the question is asking about, and then differentiate that formula using implicit differentiation with respect to time. So here, I'm just going to give you a bunch of examples because this is the best way you'll learn this topic. Question 1. Air is being pumped into a spherical balloon, so its volume increases at a rate of 100 centimeters cubed per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? So I'm going to make a small adjustment. Diameter is 50 centimeters, radius is 25 centimeters. We'll keep that in mind. And the formula we're going to use, this is about the volume of a sphere. So V is equal to 4 over 3 pi r cubed. Let's differentiate this with respect to time. So dv dt is equal to 4 over 3 pi. So it's 3r squared dr dt. Okay, so volume is increasing at 100 centimeter cubed per second. So 100 is equal to, so these threes cancel out, 4 pi, and then this is, so 4 pi times 25 squared dr dt. 25 squared, that's 625. You know what? I'm not gonna like do this super quick. So 2500 pi. Okay. Therefore, dr dt is equal to 1 over 25 pi, which roughly translates to 0.0127 centimeters per second. And this is our answer to the question. Here's the second question. A balloon is rising at a constant speed of 5 feet per second. A boy is cycling along a straight road at 15 feet per second. When he passes under the balloon, it is 45 feet above him. How fast is the distance between the boy and the balloon increasing 3 seconds later? So let's draw a diagram of this, first of all. So at t equals 0, the balloon is here and the boy is here. This is 45 feet. And at t equals 3, this is what we're being asked to evaluate. The balloon is going to be 60 feet off the ground. And the boy, well, let's see. So the boy is riding at 15 feet per second. So 3 seconds later, that's 45 feet. You know what? Let's make this a straight line. So 45 feet, because 15 times 3 is 45. And the balloon rises at 5 feet per second. So it's originally 45 feet. 45 plus 15, that's 60 feet per second. No, 60 feet, sorry. And this is the distance. I'm going to use L as a variable. And using Pythagorean theorem, you'll realize that this is 75 feet distance. So we need to use the Pythagorean theorem. X squared plus y squared is equal to L squared. So X, that's this right here. Y, that's this vertical distance right here. So let's differentiate this with respect to time. So 2x dx dt plus 2y dy dt is equal to 2l dl dt. And we've established that x is equal to 45. And y is equal to 60. No, so x is equal to 4. dx dt, that's 15. Y is equal to 60. And dy dt is equal to 5. And L is equal to 75. And we're asked to find dl dt. So let's see, 2 times 45 times 15, that's 1350 plus 600 is equal to 150 dl dt. And when you solve this, you'll get that dl dt is equal to 13 feet per second. So at t equals 3 seconds, the distance between the boy and the balloon is increasing at a rate of 13 feet per second. Question number 3. A water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. If water is being pumped into the tank at 2 cubic meters per minute, find the rate at which the water is rising when the water is 3 meters deep. So let's draw a diagram of this first. This is our inverted cone, and water is rising, basically. So we're being asked to find when it's rising when the water is 3 meters deep. So let's say 3 meters is, I don't know, right here. And you have the water being like this. Now, let me draw this small line here. You'll quickly see what I'm doing right now. So radius is 2 meters, so base radius, 2 meters, and the height is 4 meters. We have tiny r right here and tiny h right here. Now, the formula for a volume of a cone is V equals 1 over 3 pi r squared h. And you very well can find dr dt, but we're being asked to find dh dt. We're being asked to find what dh dt is, not dr dt. So what I'm going to do is I'm going to relate r to the variable h. So what we have here is we can use the method of similar triangles. R over 2 is equal to h over 4. So 4r is equal to 2h. And that means r is equal to h over 2. So v is, rewriting this equation, we have pi over 3 h over 2 squared times h, which is equal, so that means in the end v is equal to pi over 12 h cubed. This is the formula we're going to be differentiating with respect to time. So dv dt is equal to pi over 12 times 3h squared dh dt. This is equal to 1, this is equal to 4. We're told that dv dt is equal to 2, so we have 2 is equal to pi over 4 times 3 squared dh dt equal to 9 pi over 4 dh dt, and dh dt is equal to 8 over 9 pi, which roughly equals 0.28 meters per minute. And that's our answer. Okay, so we have one last question here. A streetlight is mounted at the top of a 15 feet tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. Question A, how fast is the length of his shadow moving when he is 40 feet from the pole? And B, how fast is the tip of his shadow moving when he is 40 feet from the pole? So let's draw our diagram first. So let's imagine the light is somewhere here. Light. I'm not talking about light Yagami, but yeah. Light. And this is the ground, okay? And the man is somewhere here. He's 40 feet away from the pole. Not that that matters. And let's call this length x, which is 40 meters. And he's 6 feet tall. So this man is 6 feet tall. So let's label 15 feet and 6 feet. And the light, let's say it looks, this is how, you know, science works. The light reflects down on the man's head. And this small triangle is where the light can't be reached. It's blocked. And let's call S, which stands for shadow. What we're being asked to find is the length of his shadow. How fast is it moving? So we need to find what ds dt is equal to. How do we solve this? Well, first of all, you should be able to recognize that this is actually a very good question. We're going to be using the method of similar triangles to evaluate this problem. So similar to what you saw in the last part, we're going to be using similar triangles. So here, we realize that these triangles, they have the same angle theta. They're proportionate in terms of their lengths and stuff. So the formula is 15 over x plus s is equal to 6 over s. So let's move this around a bit. 15s is equal to 6 times x plus x, or 6x plus 6s. 6x, you know what, no, let's say 9s is equal to 6x. So s is equal to 2 over 3x. So ds dt is equal to 2 over 3 dx dt. So we know that dx dt, he's walking away from the pole at a speed of 5 feet per second. So this is equal to 2 over 3 times 5, which is equal to 10 over 3 feet per second, which is roughly 3.33 repeating per second. Now B, how fast is the tip of his shadow? The tip, this point right here, how fast is this moving at 40 feet from the pole? Well, the tip is really easy to find. There's two moving forces. Tip change, don't take that the wrong way. Tip change is just simply equal to dx dt plus ds dt, which is equal to 5 plus 10 over 3, which is equal to 25 over 3 feet per second, or roughly 8.33 feet per second. So that's pretty much it for the video. I've gave you some practice problems. Once again, I only give you the final solution. I don't show you the process of how to solve this. So take an attempt at these yourselves. If you have any trouble, let me know in the comments or simply email me and I'll be happy to reach out to you. So yep, that's it for this video. See you guys next time.